If you want some of these questions to come up, hopefully some of the speakers will sort of pay attention as they come up and maybe make those sort of points. And with that, of course, I now invite Russell from BALF to give us the BALF viewpoint. Thank you, Russell.
Okay, good morning everyone. I'm Russell Smith from BALF, the Product Marketing Manager for Industrial Networking. Today I'm going to talk to you about our strategy for IR in the UK. You'll be thankful to know that I'm not going to show you the standard Industry 4 slide going from Industries 1 to 4, but we've just got a little recap here of some of the key value points that BALF can enable and that people expect in manufacturing. So hopefully we've all seen a lot of these before, but it just sets the scene for what I'm going to talk about. And basically enabling these value points is what I believe makes BALF able to be the heartbeat of an Industry 4 solution. So first things first, a little bit about us. 1921 BALF was started, believe it or not, as a sewing machine and bicycle repair shop. But funnily enough, our first product was a Spätzle press, quite a long way away from where we are now. These days you find us in most automotive plants in the UK. So we offer a comprehensive range of industrial automation products, everything from Rfid to industrial networking, machine vision, linear measurement devices, and of course sensors. Okay, so we've seen some of the value points below, but it's quite interesting just to look back and see why we look at these value points, and that's because the why for these is increased flexibility in manufacturing and efficiency. And there's another two key points, but most of our stuff falls under those two, to be fair. So here we see a typical, what we call the automation pyramid, but this basically outlines the requirements for a typical Industry 4 or 4 IR solution. And what we see here is basically we're trying to achieve communication from the enterprise level down to the sensor and actuator level. And in order to do that, we need intelligent sensors or smart sensors. We need seamless integration and communication, and also high performance interfaces, such as industrial Ethernet. There is, however, a problem, and you'll see from my diagram there that I don't show the communication fully extending to the sensor and actuator level, and that is something really we need. There is a solution, however. It's called IO-Link, and let's have a look at what this is. Easiest way for me to explain it is to show you what things look like prior to IO-Link. So if we look at this, we can see data traveling from field IO modules up through the PLC chain, up through the industrial Ethernet, and up to the higher levels of the factory. Okay, so now if we add IO-Link into the equation, what we now have is the possibility of bi-directional communication from the sensor and actuator level. And when we talk about sensor and actuator level, really we're talking about the sensors of the factory. Yeah, so we're talking about, maybe you could say touch, but certainly position. They're the eyes and ears of the factory, if you like. So what does it look like? Well, first things first, it's not another bus system. What it is, it's designed to complement your existing communication standard in a factory. So what it does is the best way I can describe it is that it's a communication protocol for smart sensors and devices. And the great thing is that we use the existing standard for connecting sensors to basically send more data down the same single wire that we used in the past. So it means that no changes have to be made to the infrastructure other than the network side of things. The great thing is there's over 100 manufacturers on board when I last checked. It's an IEC standard, it's network neutral, so it suits a lot of different manufacturers, It's a common communication standard. So this is what we need when we're talking about communicating down to the sensor level. The great thing is that the EES said, well, look, 96% of manufacturers agree the fourth industrial revolution is all about connectivity. And I think that's a great way of describing it. And what we see here is that this is borne out by the number of IO-Link nodes in the fields. Obviously that's ramping up quite quickly, in excess of 6 million devices now in the fields by the end of this year, we expect. So how does IO-Link enable 4IR? Okay, let's have a look. So I've got some IO-Link solutions here and also some RFID as well. It just shows you a little bit of some of the applications we get involved in. So let's first of all have a look at the difference between a standard sensor and a smart device or an IO-Link device. The main difference is data. Basically, a standard device such as a pressure sensor, we've got a little overview there, but in essence, pressure comes in, and in the simplest case, you literally get a digital switched output from the sensor. So either a yes or a no, or an on or an off signal. With a smart sensor, now that we have the increased communication capability, we can now send a lot more data. So not only do we have the capability to have a switch point, we've also got measurement signals. We can also send parameter data to the sensor. That means it can be set up remotely. We can also take diagnostic data from the sensor as well. In addition, on the modules, there's also increased diagnostic capabilities. So in predictive maintenance or maintenance tasks, it can make it much easier to diagnose problems. Things such as short circuit, sensor and actuator under voltage, so that'd be a cable break basically, network errors, this sort of thing. From the devices themselves, the smart devices, if we look in the case of a photoelectric sensor, it could be something like the lens is dirty. Obviously it's dependent upon the device that you're connected to. So there's lots of different types of data that can come from the sensors that would help you in a diagnostic sense. But what's also important to remember is it's not just the sensors already fit to the machines, it's sensors that you may fit to do other things, such as monitor the machines themselves. So these are sensors that aren't part of the actual production process on the machine, they're basically for diagnostics. Okay, and slightly left field of the sensing and the IO-Link side, we've got RFID, which has been in industry for years. I mean, we've had RFID products for in excess of 30 years. So this is a typical application. I'm sure Ford guys will recognize this sort of thing, but basically we can fit data bolts. So it's an RFID tag that data can be read and written to, that is basically screwed directly to an engine block or cylinder head. And this can provide us with data, head and block type for flexible manufacturing, what the supplier is, setup parameters for the machine, and quality data for test processes. If we look at tool ID, this is another aspect where RFID is being used to improve automation. And this is definitely an Industry 4 type application, but it's also one that's been in place for many years. So we can, with a machine tool, basically you need to know what the size of the tool is. Otherwise, the machine doesn't know where it's going to put it. And if you get this wrong, i.e. in the case of an operator loading it into the machine, either in the wrong pocket in the machine, or basically putting the wrong data in there, telling it's the wrong length, you can smash up your workpiece. And this is what it looks like in practice. So you've got the data coming from a tool setter, it's read and then written to the tag on the tool itself, and basically there's no scope for error. So why am I talking about this? Well, really, I'd say what we're looking at moving towards, what the end game is prognosis. And if we look in the case of maintenance, we might be looking at condition monitoring and predictive maintenance, which is what this software dashboard shows here. So really what that is taking all the data from the sensors, maybe squirting it up into the clouds, but then having some intelligent algorithms to analyze the data and predict when the machine's going to fail. Yeah, so if you know that, then you can also predict when it needs maintaining. And this to me is the low-hanging fruit from an Industry 4 strategy. It's only one little piece of it, but I think this is a great place to start. Of course, the other side of it is you can also take data from sensor machines to do data analytics. So you can achieve production optimization. Obviously, the end game there may be AI, machine learning. The machine can self-optimize. Maybe that's in the future, maybe it isn't. But at the moment, I'm not seeing a whole load of Industry 4 being implemented, so I'd probably err on the side of it's more in the future. Right, so to recap, from my perspective, the first thing you've got to do if you're looking at digitalization, and this is really simplistic, it's really high level, is you need to specify a network architecture that allows you to get data from the sensors. That's where it comes from, the machines, in the first place. So you need that communication in place so that we can access that and more of it. Secondly, we need to collect more data, utilising smart sensors, RFID, connect them via intelligent networks. I think the case is those start small. Because what I see with all this talk about I4 is it ends up in a massive picture that you can never start. And, you know, we all know with anything, you know, big jobs that we might do at home, DIY, whatever. When it's a big job, you tend not to start it. But what you've got to do is break it down. And the question is how do we start breaking that down? So I think to get to that, you have to ask the question, why are you embarking on this journey in the first place? What are you hoping to achieve? And for me, it's what Gash touched on earlier, and the way I see it is Industry 4, it has to be part of something like a lean manufacturing type methodology. So you need to start there to understand what your problems are before then you can start doing something about it. And I think that's the point I'd like to end on. Thanks a lot.